spermatogenesis, you're going to use meiosis. You start with a spermatogonium, which is like a stem cell. The spermatogonium is going to undergo mitosis, so it keeps a copy for itself for later on. Tomorrow you're going to make more sperm. And this one is going to differentiate and become sperm. So it's got 2N, which is 2 sets of 23, which is 46 total, 2N. So N is 23. 23 came from your mom, 23 came from your dad. That's why you have 2 parents, 2N. Okay? So now, it has to go to primary spermatocyte. The way you do it, other than some differentiation, is you've got to double the amount of chromosomes. So you're going to double them. I'm going to come over here. So that's the one. And it's going to undergo, in the S phase of interphase, it's going to double the chromosomes. What that means is, you see this one from the mom, one from the dad? This one doubles, and this one doubles. Okay? It's still 2N, but now you've got double the amount. Okay? So right now, we're going to come back here. So it says 46 and 46. So come back over here. You're going to have 2N and 2N. Come right back here, and this is where we are. This is called primary spermatocyte. And now you're going to go meiosis 1. Meiosis 1 will make secondary spermatocyte, but hold on, let's go over here. So, this is what we have. We have 23 of these and 23 of these. So it's 46. But we've doubled them up, so it's 46 times 2. So we got 46, 46. 46, 46. Okay? When you undergo PMAT, prophase, metaphase, anaphase, telophase. We're going to do this twice, meiosis 1, meiosis 2. So when the primary spermatocyte undergoes meiosis 1, all these double chromosomes are going to split from one another. So let's say, I'm just making it up, all the blue ones will come over here, all the red ones come over here. So now I've got 23, 23. That means I have 23 of these, and I've got 23 of these. Okay? And I have 23, 23 of these. These are called secondary spermatocytes. That's right here. You've undergone meiosis 1, so primary spermatocyte, 46, 46, secondary spermatocyte, 23 and 23. Now, we're going to undergo meiosis 2, PMAT one more time, and we're going to split it to the spermatids. So go over here. So we have these blue are going to split in half. So this blue one came here, this blue one came here. Blue, 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 blue. So they're all just basically splitting. Instead of double chromosomes, now they're single chromosomes. So now you have 23 here, okay, and this was 23 here, right? See how this is 23, 23? There, 23, 23. They're separate cells. This one also had 23, 23. So now I have 1, 2, 3, 4. These are cells, and we call them spermatids. Okay? They lose their cytoplasm, mostly. They start to grow tails, and now we call them spermatozoa. And each of them is going to be N with 23. That way, when the sperm, who is 23, meets an egg, which is 23, through fertilization, your zygote will be 46. So, this is a summary for spermatogenesis. Spermatogonium makes a copy for himself, so you can do it tomorrow, make more sperm. Okay, here it is, right here. That was mitosis. So here is the exact identical copy. So, double it. So this was 46, now this is 46 and 46. Primary spermatocyte. Undergo meiosis 1. 23, 23, 23, 23. Now you undergo meiosis 2. 23, 23, 23, 23. Lose the cytoplasm and grow tails. 23, 23, 23, 23. These are spermatids. Now these are called spermatozoa. Okay? Hold on. Bear with me. You're going to start with an oogonium way up here. You're going to undergo meiosis, but before you do it, you've got to double it. So you went from 46 to now double the 46, so 46, 46, okay, right here under primary oocyte. You're going to do meiosis 1 right here. So they shouldn't have had meiosis 1 like that. That's too high. They should have had the meiosis 1 right here. So this is 46, 46. The primary oocyte, 46, 46. Secondary oocyte is 23, 23, 23, 23. Okay? Now, secondary meiosis, meiosis 2, PMAT second time. So this secondary oocyte here, is going to go into 23, 23. This one may or may not do 23, 23. These little ones, you see how they're smaller? They don't have much of the cytoplasm. The cytoplasm is going to go into this one. This is the one that the sperm is going to eventually fertilize. So these polar bodies tend to be much smaller. So this is going to be 23, 23, okay, if it undergoes meiosis 2. This secondary oocyte, why do they have a sperm here? Because this secondary, this is the same thing, right? Just moved from here to here. It's the exact same thing. This is still 23, 23. It will freeze in meiosis 1 until a sperm comes along. And when the sperm comes along, then it'll say, let me go through meiosis 2 at this point. And now this 23, 23 splits, and now you have 23 and 23. This again loses its cytoplasm to this one. See, it's getting bigger and bigger. And this one is a polar body, throw it away. And this is the only one that's 23 that'll get fertilized. So the secondary oocyte is the one that gets ovulated. That's what you should remember. The secondary oocyte is the one that gets ovulated and will only do meiosis 2 once a sperm is there. If a sperm is not there, it will disintegrate still in meiosis 1 and just get removed from the body. Okay? If this is oogenesis, this is the oogonium, 46. Then primary oocyte, 46 and 46. Now, meiosis 1, secondary oocyte, 23, 23, 23, 23. Then here, this is meiosis 2. Now these are not spermatids. Remember, these are oogenesis. So it would be 23, 23, 23, 23. But remember, this is a polar body. That's a polar body. That's a polar body. And this is the only one that will be your secondary oocyte that is going to be fertilized. And that's only when a sperm is there. Because that's the one that gets ovulated. Okay, good. Okay, so this is the ovary, this is the medulla, and this is the cortex. And the follicles and the oocytes are developing in the ovarian cortex. Now you have, remember that there are oocytes, and the oocytes are going to develop inside areas that are filled with these big grouping of cells. Those cells are called follicular cells. When there's one layer, it's called follicular cells. When there are 2 or more layers, they're called granulosa cells, or just granulosa. If you put follicular cells, I'm not going to mark it wrong, but just to make sure 2 or more traditionally are called granulosa cells. So those cells are not part of the oocyte. So we have oogonium, and then inside this follicle, you have a primary oocyte, right, which is 46, 46. Then it's going to stay like that. Primary oocyte, primary oocyte, primary oocyte. Yes, I know it's a secondary follicle. So primary oocyte, and right here, right before it ovulates, it undergoes meiosis 1, and now a secondary oocyte is what's going to be ovulated. So that is a secondary oocyte. Okay? What's left afterwards, that goes down the fallopian tube, through the fimbriae and through the fallopian tube to get fertilized or to be thrown out. What's left are these granulosa or follicular cells, and we'll go over that. So basically now we're looking at follicular cells. These are primordial follicles here, and you can see that they have little nuclei. This is a primary follicle. You see how these are like just dots, not really organized well. There now is I have one layer of follicular cells. I'm beginning to see that it's starting to form more. So they're starting to form 2 layers. I'm not quite sure how many layers. I can't see it really well. But now they're called granulosa cells. This is a primary follicle, a primary follicle, a primary follicle. Now you start to see the formation of an antrum. As soon as it starts to form, call it a secondary follicle. This one, you can see the antrum is much, much larger, this antrum fluid-filled space. And this, so the antrum is getting larger, larger, larger. And so now, even though this is primary oocyte, primary oocyte, primary oocyte, primary oocyte, now this is going to become a secondary oocyte here right before it ovulates, because it's going to undergo meiosis 1. This is called the mature follicle. As you see, a huge antrum, and the bulging at the very edge of the ovary. The fimbriae are going to come by and kind of scrape away at this to help release it. This is the ovulation of the secondary oocyte. You have the corona radiata, which are some granulosa or follicular cells around it. This clear or white part around it is called the zona pellucida. Over here you have the theca, which is kind of a protection around there. This is going to go down the fallopian tube, whereas this is going to become, it's going to start to fill up with blood and clot, and then so it's going to close up. So this now is going to be called corpus hemorrhagicum, because it's hemorrhaging inside and then gets clotted blood. Then it starts to form the corpus luteum. Luteum means yellow. So now this is a really nice big yellow thing which produces progesterone and a little bit of estrogen. This is the corpus luteum, which will continue to produce progesterone for about 10 days. And then it becomes the corpus albicans. Albino is white, so it becomes corpus albicans, and then it will start to turn into atretic little follicles, which will start to fall apart. So right here again, it's in the cortex, not in the medulla. Primordial follicle. This should not be the primary follicle. This is the primary follicle. That's the primary oocyte. So primary follicle, primary oocyte. This is a secondary follicle. The antrum is already starting to get a little bit bigger. That's still the primary oocyte. This is a mature follicle, a very large antrum, and this is starting to form into the secondary oocyte with its zona pellucida and corona radiata and the theca out here. This is now ovulation of the secondary oocyte with its corona radiata and the zona pellucidum. Corpus hemorrhagicum, corpus albicans, corpus luteum would be nice if they made it more yellow. Then it turns into a corpus albicans, which is white, and then it turns into atretic, and then it goes away.